Hi, so this is question 7 on homework sheet 21. I'm going to try and talk you through my workings. Hello, sorry, busy house here. Right, the total surface area is going to be half the surface area of the sphere plus the surface area of the cylinder and the area of the circle on the bottom of the flower shaker. So I've halved the formula they've given me for the area of the sphere. The surface area of the cylinder, well, that's going to be the circumference of the circle times by the height. If you think of it, if you roll that up to make this, that bit is this length here, and that's the height. So 2 pi times 2r times h get you the surface area of the cylinder and then the area of the circle on the bottom of the flower shaker. Tidy that up and you should have this. If you look at what they want to give though, they haven't got h, so you've got to find a way of getting rid of h. They tell you that the volume of the cylinder, or the capacity, is 200 centimetres cubed. So that 200 centimetres cubed is going to be equal to the volume, which is the cylinder plus the hemisphere. So pi r squared h plus a half times the formula for the volume of a hemisphere. Tidying that up, if I go down, you end up with this here. And if you, there we go, there's the version. If you sub that into equation 1 from earlier, which is up here, there we go, you can eliminate h. There's my workings there. So just substituting in, multiplying out, the pi and the r will cancel with this one. And then this gives you the total surface area. So think about converting that one into 9/3. 9/3, take away 4/3 is what gets you the 5/3. So that's part A. Part B, they talk about wanting to minimise the cost of production by minimising the surface area. So you need to differentiate your surface area to find the minimum surface area. So there's your surface area from earlier. What I like about this question is in part A, they give you enough information to go on and do part B. So if you can't do part A, you can still pick up the marks in the second part of the question. So we've got this. I've written it so that I've taken the R up into a power. And then I've differentiated to get this. If I set that equal to 0 and rearrange, I get r cubed is equal to 120 over pi. So therefore r is equal to this, 3.367. The issue is we don't know whether that's a maximum surface area or a minimum surface area. And we can check that by differentiating a second time to find if it's a maximum or a minimum point. So if we differentiate a second time and substitute r in as 3.36, we will get this 31.41, which is greater than 0. Therefore, that's a minimum point and it's the minimum surface area. You must show that if you're wanting to get full marks, because it says justify your answer. So r is equal to 3.37 centimetres. The next, the question says find the dimensions. So not only do we have to find r, we also have to find h as well. So if we sub that back into equation 2 from part A, we'll end up with h is equal to 3.36 centimetres. The next question, part C, says state one limitation of the model and suggest an improvement. But they haven't thought about the thickness of the material. So there's no point minimising the surface area if you're using a really thick material. I hope that helps. Give me a shout if you need any more help on anything. Thanks.